There are so many videos out there teaching how to create this AI workflow, that AI workflow, but that doesn't give you the knowledge to create AI workflows on your own or leverage the full power of N8N. Instead, what you need is a complete guide that explains all the AI related nodes present in N8N. What's their purpose, why, when, and how to use them. In this masterclass, we will deep dive into N8N's AI capabilities. Whether you're a beginner or have some experience, by the end of this video, you will be equipped to create powerful AI workflows on your own. Let's start by breaking down what AI agents are. In simple terms, AI agents are autonomous programs that can perform tasks using artificial intelligence. Think of them like little digital workers. They perceive their environment, they process information, and then they take action to achieve specific goals. It's like having your own personal assistant, but powered by AI. They can do everything from sending automated emails, analyzing data, or even holding conversations with users. And here's the best part, you don't need deep technical knowledge to use them. With tools like N8N, you can put these AI agents to work without writing a single line of code. Now let's talk a little about N8N. If you are not familiar, N8N is an open source no code workflow automation tool that empowers you to connect different applications and services. It's a really good alternative for applications like make.com or Zapier. You can watch this video to see how to install it locally or host it on your own cloud VM. Now let's dive into the N8N dashboard and explore all the AI related nodes available. Now the first node has to be a trigger node. For now, let's select trigger manually. Now if I click on plus button here, we see all the nodes present in N8N. And in this video, we are mainly interested in advanced AI nodes. If we go inside this, we'll see all of these different node categories. At the top, you will see AI templates. If you click on this, you will be taken to a website page where you can find the pre-created AI workflows. Then there is AI Agent, then OpenAI. Then there are 3 pre-created chains: Basic LLM Chain, Question and Answer Chain, and Summarization Chain. And at the end, there are a bunch of AI nodes. If we go inside these, you'll see a long list of categories of nodes that we can use in our workflows. Now this may seem overwhelming, but don't worry. We'll go through all of these nodes in just a few minutes and understand why, when, and how to use these nodes. And by the end of this video, everything will be crystal clear. If you haven't subscribed the channel yet, do subscribe the channel and hit the bell icon so that you don't miss any future updates. In the next couple of videos, I'll show you how to set up N8N for production applications, how to use external databases, how to attach the external memories, how to use the nodes in a correct way, and we'll also develop some really interesting AI workflows. So stay tuned for that. Now here, we will understand all of these nodes in 3 categories. First, we'll talk about the AI agent. In the second category, we have these pre-created chains. And in the third category, we will deep dive into all the other AI nodes. Let's start with AI agent. If we select this node, we will see a window like this. Now, in the drop-down, we can see there are multiple agent types. We have Tools Agent, Conversational Agent, OpenAI Functions Agent, Plan and Execute Agent, React Agent, and SQL Agent. We'll talk about each of these, but before that, let's talk about some common features that all of these agents provide. So here, in the prompt, we have 2 options: take from previous node automatically or define below. Most of the time, we want to take the input from the previous node. However, you can define your prompt here as well. Next, we can define the specific output format that we want. So we can enable this flag here, and it will give us an option to define our output format. And then it will convert the response that it prepares to match our format before it outputs it to the next node. Now there are a bunch of options that we can configure for these agents. We can set system message to guide the agent's decision making, define the maximum number of iterations for generating responses, and choose whether to include intermediate steps in the final output. These settings give us control over how the agent operates within our workflow. And at the bottom, we see these 4 options. Now, not all of these options may be present in different agent types. We'll talk about that in a bit. The first option enables us to select the model that will be used by this AI agent. So if I click on this, we will see a list of language models that we can use with this particular agent type. Next, there is an option to add the memory to this agent. Now, certain agent types may need memory to process the request. In those cases, we can click on memory and we can add these memory nodes. Now, the first option is the easiest one, window buffer memory. It will use the memory of the VM where this workflow is running. It is not recommended if you expect a large number of workflows to execute in parallel on your host, because it will consume the memory of your host and make the workflows slower. If you are trying to deploy a production application with a large number of workflows executing in parallel, you want to use an external memory, like Redis chat memory. Next, we have an option to add tools to this agent. Now, these are the different tool types that we can add. We have calculator, custom code tool, HTTP request tool, sub API, vector store tool, and so on. The most interesting node out here is the custom code tool. Now, in this node, we can give a name to this tool. Then we need to give a detailed description of what this tool does and when to call it. Then we have two language options, JavaScript and Python, and we can put our code here. Now AI agent will have access to all the tools attached to it, and it can execute them if required. And finally, we have the output parser. Now if we have this required specific output format enabled, we will have this option here. And we can attach an output parser. We have three options for this. Auto-fixing output parser. It automatically fixes the output if it is not in the correct format. Then we have item list output parser and structured output parser. The third one is pretty amazing. It allows us to give a JSON formatted output that we expect this agent to return, and the agent will return the response exactly in that format. So if I select structured output parser, we can define the JSON here. Now let's go through each of these agent types. Conversational agent is designed for human-like conversations. This agent maintains context over multiple queries and understands user intent. It's ideal for building chatbots, virtual assistants, and customer support systems. Next, we have OpenAI Functions Agent. It utilizes OpenAI's function calling feature to select the appropriate tool and arguments for execution. It is best suited when integrating with OpenAI function models. So if we click on the models, we will see just two options, Azure OpenAI or OpenAI Chat. Third, plan and execute agent accomplish an objective by first planning what to do and then executing the subtasks. It is perfect for complex tasks that need to be broken down into manageable steps and execute them one by one. It doesn't use the memory and instead focuses on executing the current task. So we don't have a memory option here. Next, we have the React agent. It implements reasoning and acting logic, reasoning about tasks, determining necessary actions, and executing them iteratively. It's suitable for complex problem-solving tasks that don't require conversational context or memory of previous interactions. Then we have SQL agent. This agent interfaces with SQL databases, converting natural language queries into SQL statements and executing them. It allows users to query data without any SQL knowledge. It works with MySQL, SQLite, and Postgres databases. And at the bottom, we see two options, model and memory. And finally, we have Tools agent. It uses external tools and APIs to perform actions and retrieve information, deciding which tool to use based on the task. So at the bottom, we see all of these four options for this agent type: model, memory, tool, and output parser. Now let's see when to use which agent. If maintaining conversation history is important, the conversational AI agent or OpenAI functions agent are preferable. For tasks not requiring memory, you can consider the React AI agent. For complex tasks requiring planning and step-by-step execution, the plan and execute node is suitable. For problem solving without the need for conversational memory, you can use React AI agent. You can use SQL AI agent when interacting with SQL databases. You can choose Tools AI agent for workflows involving external tools and APIs. As an example, let's select Tools agent for now. And then let's select the model to be OpenAI chat model. Next, let's attach the memory. I will just select the easiest one, window buffer memory for now. And let's attach one tool for now, calculator. And this is how our AI agent looks like. Now we can attach the next set of nodes to take action on the message written by this AI agent. So let's say I want to save the output in Google Sheet. So I'll add a node to append or update the row in a sheet. Let's say I also want a notification message on our Slack channel. So I'll add this send a message Slack node over here and connect it with this node. Now we can keep adding more and more nodes depending on our requirement. But you get the idea, right? So this was our AI agent. And let's talk about the chains provided by N8N. Now before that, let's take a quick look at OpenAI node. You can message an assistant or GPT or analyze images, you can generate audio, etc. with this node. And we can see all of these actions. We can create assistants, list assistants, message or update an assistant. We can directly message a model. We can even analyze and generate images. We can also generate audio, transcribe or translate a recording. And we have the file actions to delete a file, list a file, or upload a file. Let's say I want to generate an image. So I can select this. Then I can select the credentials, select the resource type as image because I want to make a call for this resource. And then the operation name. It can be generate an image, analyze image, or custom API call. I can select the model from here and give a prompt. Now let's talk about the basic LLM chain. It's a really simple chain to prompt a large language model. So what's the difference between this OpenAI node and the basic LLM chain? So if you look at this node, we have option to require specific output format. It means that we can control the format of the output. Another difference is we can add multiple prompts here. In the prompt type, we can select AI, system, or user. Now this node will receive an input. It will make a call to the LLM and return the output. Next, let's talk about question and answer chain. Now this is basically a RAG internally. If you have certain files or documents and you want to create a workflow that takes the user's questions, searches for the answer in those documents, and then return the customized response to the user, then you can use this chain. We will look at the detailed usage of this chain in just a few minutes while going through the other AI nodes. And finally, we have the summarization chain. It transforms your text into concise summary. We have the option to select the node input. The input can come as a JSON or binary data from the previous nodes, or we can use the document loader. Document loader will load a document and provide it as an input to this node. Then we have the chunking strategy. We can keep it to simple or advanced. With simple chunking strategy, we can select the number of characters per chunk and the chunk overlap. If we select advanced chunking strategy, we get an option to add the text splitter. If we click on text splitter, we get these three options. We can split the document as per the number of characters or the tokens. And here we can select the model for this summarization chain. And this is how our simple summarization chain looks like. Now let's move to the most important part of this tutorial, other AI nodes. Let's bring everything we have learned together by walking through a practical example, a document question answering system. We will use this diagram to first visualize the workflow and explain each component involved. This will help us to understand how all these pieces fit together in an actual N8N workflow. This Q&A system will have two parts. First is upserting and second is querying. Upserting flow will process our files and make them searchable by our system. In this flow, first we will load our documents using a component called document loader. After loading the documents, we will split those documents into small chunks. After splitting them, we will use the embeddings model and convert those chunks into vectors. And finally, we will store those vectors in a database called vector store. Now we can query this database for a question and we can get the related text. Now in the second flow, we have the chat flow where a user will ask a question using a chat component and then his query will be converted into a vector using the embeddings model. And then the retriever component will do a similarity search of that query in the vector store. Once the system gets the similar results, it will build the context. And finally, it will make a call to the LLM. along with that context. And LLM will return a personalized response on the basis of the entire context that it received. And finally, the response is returned back to the user. Now, if we want to return the response in a particular format, we can use output parsers. Now let's build this entire system in N8N. I'll start with a trigger component. Now let's say our documents are in Google Drive. So I'll add a Google Drive node here to download the file from there. And here we can select the credentials and the resource type is file and operation is download. And then we can select the file from here. Now we need to convert this document in vectors and store it in a vector store. So I'll go here and in the vector stores, I will select Pinecone vector store. You can select any other vector store as per your requirement. Here I can select the credentials and I want to insert the document. So I'll select insert documents. And here we can select the Pinecone index. Now I'll connect Google Drive to this node. And here you can see we need to connect embedding and document. So we need to connect the embedding model. I will select embeddings OpenAI. You can select any one of these. Next, we need to connect the document loader. So we can click here and select one of the document loader from here. We have two options, default data loader and GitHub document loader. Default one will load the data from the previous step, whereas GitHub document loader will use GitHub data as input to this chain. I'll select the first one. And here the type of data will be the binary. I'll leave the data format as it is. And now we see an option to add text splitter to this node. I'll click here and to keep this thing simple, I'll select character text splitter. You can split the file as per the characters or the tokens. Here I'll keep the chunk size as 1000 and chunk overlap as 50. And this is how our workflow looks like now. Now, if we look at our diagram, you can see we had a document loader, then we were splitting the text, then we were converting those chunks into vectors using embeddings model, and then finally storing it in the vector store. And now if we look at this workflow here, we are downloading the file from Google Drive and passing it to this Pinecone vector node. Now this node has access to the embeddings and it has access to the document loader, and document loader has access to the splitter. So this document loader will receive the file downloaded from Google Drive and it will split as per this splitter node. And this Pinecone vector store node will use this embedding model to convert it into vectors and store it in the Pinecone vector store. Now let's work on our second part of the system, where a user will start a chat, he'll ask the question, then we'll convert that question into vectors using the embedding model. Then we will use the retriever node to do a similarity search on the vector store that we just created. Then create a context out of it and make a call to the LLM. Now to do all of that, we will use question and answer chain. And it will receive the prompt from the previous node. So we can add a chat trigger to this. And now we need to add the model and retriever. So I'll select the model as OpenAI model and select the retriever from this list here. The contextual compression retriever enhances efficiency by compressing the retrieved documents before passing them to the language model. It identifies and retains only the most relevant information necessary to answer the query. And this way it improves the response accuracy and speed. The vector store retriever uses vector embeddings to find documents that are semantically similar to the user's query. The multi-query retriever enhances the retrieval process by generating multiple variations of the original query. By doing this, it is able to retrieve a broader range of relevant documents from the vector store, and in turn, it improves the quality of the response. And then we have workflow retriever. Now, instead of fetching documents from some external database or vector store, this node can pull information from the previous nodes or steps in your workflow. In our case, we want to use vector store retriever. Now in this node, we need to select the vector store from where we want to retrieve the information. So I'll click here and select Pinecone vector store because that's where we stored our information. And here, this time we want to retrieve the documents instead of inserting them. And we need to attach the embedding model to this Pinecone vector store. So we can click here and select the embedding model. And this is how the second part of the system looks like. Now what we want to do is move this first part of the system where we are storing the documents in the vector store to a separate workflow and execute it once, because we don't want to convert the same documents into vectors again and again. So we will execute this workflow only once, and then this workflow can be executed by using chat as the trigger. So user will ask the question, it will be passed on to the question and answer chain. Then chain will use the vector store retriever to extract the similar content from the Pinecone vector store. And Pinecone vector store will use the embeddings to convert the user query into vector and then search it in the vector store. And then it will return the response back to the question answer chain. Then Q&A chain will put the response in the context and make a call to this OpenAI model to get the response. And finally, it will return the response back to the user. And this is how all of these different nodes work together to build really powerful workflows. We have seen all of these nodes in action in our Q&A system. Document loaders are used to load the documents. Memory stores the conversation history or state between interactions. Text splitter is a tool that splits large documents into smaller, manageable chunks. Output parsers parses and structures the output from the language model if necessary. They are used to extract specific information or format the response before sending it back to the user. Retriever nodes enables us to find the most relevant document chunks based on the similarity between embeddings. They are used to retrieve only the most relevant pieces of information to answer the user's question accurately. Embeddings generation is the process of converting text chunks into numerical vectors that capture the semantic meaning of the text. Embeddings allow us to perform similarity searches between the user's questions and the document chunks. Vector store is a database optimized for storing and retrieving embeddings. It is used to store the embeddings so we can quickly find and retrieve relevant document chunks when a user asks a question. And this pretty much sums up everything we have related to AI in N8N. By now, you should have a solid understanding of N8N's AI capabilities and feel confident in building your own AI workflows, even without any technical background. In upcoming videos, we'll explore how to use N8N in production, how to use external database and memory, and how to update N8N version without losing the data. We'll also build some really complex and interesting workflows in N8N. If you found this video helpful, please give it a thumbs up and consider subscribing so that you don't miss out on future content. Feel free to leave comments and questions below. I'd love to hear about the AI workflows you are building with N8N. Thank you for watching and see you in the next video.